Now, given the fact that SQL is a declarative programming language, the question arises, how is an SQL statement like the one that we saw, right? Very simple SQL statement. We want to select all the movie names from the movies table where the year is greater than 0. We are just saying what we want. Now the big question here is, how does an SQL statement get executed to result in the solution that we want? So every database, right? A database has a lot of software which helps us execute the SQL. That's one of the big advantages of databases over flat files. You can just give your SQL query, you can shoot your SQL query to the database. The database would return the answer that you want. That's the power of a database. So internally what's happening here is an SQL, so given an SQL query, internally what's happening, there are a couple of stages. I'll briefly explain them. To deeply understand them, there is a lot of computer science that you need to learn. For example, so as soon as an SQL query is thrown into a database, the database itself will contain lots of things. One of them is called a parser and a compiler. What this does is, it takes the SQL query, it understands the SQL query. It tries to understand what is the SQL query trying to obtain. Okay, it tries to understand the query. And once it understands the query, parsing actually tries to break your SQL statement or SQL query into smaller components. For example, it will say, okay, it wants data only from movies table, and it only wants the column movie name, and it wants this wherever the year is greater than 0. It tries to parse this information, right? And the compiler then generates code. In one of the procedural languages like C or C++ or Java or Python, whatever is the programming language that the database uses. And most databases typically use C or C++. Some databases also use Java, okay, because they're extremely fast. So the parser and compiler takes the SQL query, understands what is there in the SQL query, compiles them into a procedural program. That's the first step. The second step is, once this part is done, there is something called a query optimizer. This is a very, very important part. So query optimizer says, given this query, what is the optimal way to execute this query? And query optimizer is a whole area of research in itself. Like, I know people at top universities whose career has been spent researching on query optimizers. It's a vast, vast area. But in a nutshell, it says, because we already understood what it wants, we have some code snippet. Again, code snippets in some databases can be generated by the compiler. In some databases, it can be generated after the query optimizer also, right? Once the query optimizer decides what is the best way, what are the best data structures to use, what is the best sequence in which I have to perform operations, right? There are many, many components of a query optimizer. And then there is a query executor, right? The query executor at the end of the day executes the query, right? The query executor at the end of the day executes the query, literally the code on the database, and whatever it retrieves, we get it back. We get the results back, right? So these are again, I'm simplifying it a lot. I'm simplifying it by a wide, I have skipped a lot of things. But it's good to understand that there is a component within the database which parses the SQL query, so that if there is any error in the SQL query syntax, the parser throws an error saying, yes, there is an error in your SQL query, right? The query optimizer, the compiler again converts this into some procedural language so that it can actually execute this. See, at the end of the day, you can't execute an SQL query. You need code in C, C++, Java, or Python, because your computers will again convert this code into machine level language and execute them. To understand how parsers and compilers work very deeply, you have to know a whole subject called compiler design. There is a whole subject called compiler design, which explains how parsers and compilers are designed. And this is a subject that we typically learn at undergraduate level computer science, right? Again, a query optimizer, and this is a semester long subject. Okay, it's not a topic, it's a whole subject. Similarly, query optimizers is a very interesting area that typically people learn at graduate level, at master's or PhD level. People who are pursuing PhDs or masters in computer science or databases, they tend to learn deeper into how query optimizers work. And then the executor basically ensures that all of the code, all of the optimized code is executed and the results are given back, right? So these are, again, this is a very, very simplified view. This is a very, very simplified view, trust me, right? And I'm just informing you this because there is something called a query optimizer which internally optimizes your queries. And every database, MySQL might have a different query optimizer, IBM's databases will have a different query optimizer, Oracle's databases will have a different query optimizer, etc. The parser compiler part of it also will differ from each implementation. The standard here is the SQL. SQL is a standard. How the parser is implemented, how the query optimizer is implemented is up to the database designer, right? Which is either MySQL or the engineers at Oracle or the engineers at Microsoft when they design SQL Server, etc. It all depends on how these guys, how the engineers at these teams implemented these things. But SQL itself is an industry-wide standard.